Battle of the metals. Titanium versus tungsten. Which giant comes out on top? Hey, engineering enthusiasts! Today we're stepping into the ring to witness one of the most fascinating duels in the world of materials. Imagine you need to build something that pushes the limits, a plane that flies higher, an implant that bonds perfectly with your body, a tool that cuts through the hardest steel, or a filament that withstands extreme heat. But who are the real champions when the pressure is at its highest and the conditions are extreme? Today, we'll put head-to-head two of the most impressive metals known to engineering, titanium and tungsten. One is known for its unmatched lightness and strength, the other for its hardness and melting point that challenge any furnace. But which one is the most versatile, which stands out in each category, and in the end, which would come out on top in this battle of metallic giants? To begin with, we need to understand that titanium and tungsten are not common metals you come across in your daily life, like iron or aluminum. They are special materials, handpicked by engineers for tasks where other metals would simply fail. Both have characteristics that make them unique, but their strengths lie in very different aspects. Let's start with our first gladiator, titanium, discovered at the end of the 18th century and named after the Titans of Greek mythology, who were known for their colossal strength. Titanium took a long time to be purified and to have its properties truly understood. But after all, what makes titanium so special and why is it so valued? The answer lies in an almost magical combination of properties. It is incredibly light, but at the same time, it has impressive mechanical strength, often surpassing steel in its strength-to-weight ratio. Think of a material that is almost as strong as steel, but weighs about 45% less. In addition, titanium is a master at resisting corrosion. And why is titanium almost invulnerable to corrosion, even in harsh environments like seawater or certain acids? When titanium comes into contact with oxygen, it forms a thin layer of titanium oxide, which is extremely stable and passive. This layer acts as a protective shield, preventing the underlying metal from being attacked. It is this characteristic that makes it ideal for naval components and chemical equipment. And what's more, titanium has incredible biocompatibility. It is not toxic and does not react with body tissues, allowing bones to grow and integrate directly with its surface, something essential for prosthetics, pins, and dental implants. Its melting point is high, around 1668 degrees C, which makes it suitable for high-temperature applications. Although it's not the absolute champion in this regard, now let's get to know our second material, tungsten. The name tungsten comes from the Swedish tungsten, which means heavy stone, a reference to its remarkable density. Also discovered at the end of the 18th century, tungsten quickly gained notoriety for its extreme properties. But what makes it a denser and harder metal among pure elements? And why does it have the highest melting point of all known metals? The answer lies in its atomic structure and in its metallic bonds, which are incredibly strong between its atoms. These bonds require an enormous amount of energy to break, resulting in a remarkable melting point. About 3,422 degrees C, the highest among all metals, and the second highest among all elements, second only to carbon in its graphite form. This extreme density and hardness make tungsten the material of choice for applications that require maximum resistance to wear and deformation. It is so hard that it is used in high-performance cutting tools, capable of machining other metals and alloys with ease. However, despite all this hardness, why is it so brittle at room temperature? Paradoxically, the same atomic structure that gives it hardness and a high melting point also makes it relatively brittle and fragile when it is not at high temperatures. This means that although it resists scratches and deformations, it can break or chip upon impact. The tensile strength of tungsten is also impressive at room temperature, but its strength-to-weight ratio does not compare to that of titanium. With the introductions done, it's time for the battle to decide which metal comes out on top. Let's compare them in different categories. First, in mechanical strength and lightness, titanium is the undisputed champion. Its strength-to-weight ratio is superior to almost all engineering metals, making it irreplaceable. In the aerospace industry, where weight is a critical factor for light and strong structures, titanium stands out for its hardness and strength. Abrasion-resistant tungsten, especially in its alloys like tungsten carbide, excels in its ability to resist scratches, cuts, and abrasion. It is unmatched, being the choice for drill bits, milling cutters, and cutting tools for extreme temperatures. With its record-breaking melting point, tungsten comes out on top. It is used in lamp filaments, furnace heating elements, and in applications where other metals would simply melt. And when it comes to corrosion resistance, titanium, with its protective oxide layer, shines in this category. It is ideal for saline, acidic, and alkaline environments, where the integrity of the material is crucial. Finally, when it comes to density, it's definitely tungsten, with its density almost twice that of lead and about 2.5 times greater than titanium. It is used where mass is needed in a small volume, such as in counterweights and armor-piercing projectiles. Well, the practical applications of each one clearly illustrate their victories in different scenarios. Titanium is the star in airplane fuselages, rocket components, orthopedic implants, high-performance bicycles, and jewelry. Tungsten, on the other hand, is found in incandescent lamp filaments, ballpoint pen tips, balancing weights, tungsten inert gas welding electrodes, and of course in ultra-resistant cutting tools, and even in armor and ammunition. However, no metal is perfect. Titanium, despite its qualities, is expensive and relatively difficult to machine and weld, requiring protected environments and avoiding contamination by oxygen at high temperatures. Tungsten, in turn, is notoriously difficult to work with due to its hardness and brittleness at room temperature, and it is also expensive. In the end, this battle of metals doesn't have a single universal winner. Titanium and tungsten are champions in their respective arenas, each with a unique set of properties that make them irreplaceable in certain applications. Titanium is the lightweight and strong warrior, master of corrosion and biocompatibility, while tungsten is the tough brute, king of high temperature and wear resistance. The real victory lies in knowing how to choose the right metal for the right challenge. If you've made it this far and enjoyed the video, make sure to subscribe if you haven't already, leave a like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content and to be remembered in our videos. Seen any cool uses of titanium or tungsten in daily life? Share in the comments. I'd love to hear. Right here on the side, there are 2 interesting video options you need to watch to expand your knowledge and explore your curiosity. If you'd like to support us, please like, subscribe, turn on notifications, or become a member. Thanks, engineering lovers. See you in the next video.